writing them in order, 1, 2, 3, blah, 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 or I usually write them in pairs. That'll make sense to you in a day or two. So 1 goes with 24, 2 and 12, 3 and 8, 4 and 6. So that's all the factors.
That's what I did, but then I know the factorization tree.
Well, that's what this is. To go all the way, so on B, it's all the way down to prime factorization, which means all the numbers have to be prime numbers, but on the first one, it just said all the factors, so it doesn't matter if they're prime. So on B, they asked for prime factorization, so I'm going to use a factoring tree. You can use whatever 2 factors you want to start. So prime factorization would be 2, 2, 2, 3, and 3. Everybody remember that? And then it says simplify 36 over 48 using the greatest common factor. So 36 over 48. What is the greatest common factor in those two? 12. So you divide by 12 over 12 and get 3/4. All right. Everybody remember? Good. I want to call Miss Marshall and have her come up here and remind you guys. Okay. So what does it mean? So what does it mean to factor a number?
Make it like the simplest number.
Exactly. What are factors?
Whatever times the number that equal that number.
That equal it how?
I'm multiplying.
There you go. That's the important thing because don't 20 and 4 also equal 24? But I didn't write those down. Right?
True.
Because those aren't factors. Factors are the numbers you multiply to get an end result. So, let's see, how should we say it? Okay, so what we did at the top was middle school factoring. It's actually even maybe a little bit of elementary school factoring. I think you start talking about factors and multiples in the 5th grade. So factoring, once you get to high school, gets a little bit different, a little bit more complicated because we start to throw letters into everything, which is why we had to review polynomials yesterday. So yesterday when we were doing our polynomials, we were multiplying two binomials, so we FOILed them or distributed them. So they did that for us right here. They multiplied, just make sure everybody's with me and following along, they multiplied 2x times 4x, and that's where they got 8x squared. And then 2x times y gave them 2xy, and then they did 3x times 4, 3y times 4x, and got 12xy, and then 3y times y would give you 3y squared. That's where this came from. That is just combining like terms. Everybody good? Okay. So, considering what we just said factors were, consider this polynomial that we just talked about. What are the factors of this polynomial?
2x, 3y.
Very good. 2x plus 3y is the first factor, and 4x plus y is the second factor. They are the things that you multiplied to get this polynomial. Okay, so if these are my factors, what is the product?
X squared minus 49.
X squared minus 49. Remember, we talked about these yesterday. These are conjugates of each other. They have the same terms, x and 7. One is plus, one is minus. So when you have conjugates, you don't have to F and IL, you just have to F and L. So it's x squared minus 49. Okay, so what does it mean to factor a polynomial? So if we have this, and I ask you to factor it, what do I want you to do?
Break it down.
Break it into the polynomials that you multiply because these are still polynomials too, right? They're just binomials. So we're gonna break bigger polynomials down into the smaller polynomials that you multiply to get that as an end result. So it means the same thing. Okay, so factoring is actually quite involved because there are multiple, we learned yesterday, we have monomials, we have binomials, we have trinomials, and then after that, there get to be so many, we just start calling them all polynomials. But we have polynomials with 4 terms, we have polynomials with 5 terms, 6, 7, we can have as many terms as we want in a polynomial. So there are multiple ways to factor then, depending on what type of polynomial you're starting with. Factoring is also probably the most important thing that you learn in all of algebra. I say that because I teach Algebra 2 and Pre-Cal and Calculus and College Algebra, and if you can't factor, you won't pass the classes after this one because it stays with you forever. This is not I'm going to learn this, pass the test on this, and then I'm going to forget it and move on. Because what will happen is we're going to factor, and then the next unit that we do, I'm not even going to mention factoring or talk about it anymore, but you might use it on every single problem that we do. So this is a remember it forever. Well, at least until you get to stop taking math. So because of that, I teach it very slow. And I review it a billion times. And what will happen starting, not next week because it's going to take us a full week to learn all of the factoring methods, but the week after that, I'll start giving a quiz every Friday on factoring until everyone passes. So last year, thanks to one particular student, which I'm sure some of my seniors will tell you who it was, I think we took 14 factoring quizzes before everybody learned to factor. But for those of you who know how, it's like a 300, right? Because once you learn how, you know how. So, but it won't start until we're going to learn them all, and then we'll start taking factoring quizzes because it's hugely important. Okay, so today, I'm going to teach you. And you know what? These you should already know. You did this in 9th grade. You didn't do them all because there's no reason for you to know them all in 9th grade. But we don't even do them all in here, but we do more than you did in 9th grade. These first 2 you should know, but they're the easiest 2. We're going to start with those 2 today, and then on Monday we'll do another one.
How many ways is there?
Several. Okay, so the first part of factoring, now this has nothing to do with what size of polynomial it is. This has to do with every single problem. Every single one of them could have a greatest common factor. You have to check that first, no matter what. Because later on, if you don't check and you just launch into one of the other kinds of factoring, you'll work the problem, you'll get an answer, and it will be wrong because you didn't factor out the greatest common factor first. So no matter what, you have to look at it first and ask yourself, okay, is there a greatest common factor? Just like we did with this, we looked at both numbers, 36 and 48, and we figured out what number is a factor of both of those. That's what finding a greatest common factor is. It doesn't change because this is algebra. The only difference now is there are letters, but that's okay. We can handle letters. So I look at this one, and I ask myself, 6x squared and 14x. What could possibly go into both of those terms? Not just 2, 2x. Because they both have an x on them also, right? Okay, so that is the GCF. So I'm going to write down what the GCF happens to be. Now, when you factor a polynomial, factors don't disappear. They have to remain in the problem. So I'm going to write a 2x right here. And then I'm going to put inside the parentheses, what would be left if I divided the 2x out of each piece? So if I took 6x squared and divided it by 2x, what is left? 3x. And if you divide 14x by 2x, 7. Because you took the x out. Yep, everybody good? Now, you can always check yourself, because if you were to redistribute that 2x, you should be right back where you started. Right? Okay. Now, a little bit more complicated. It only has a GCF if there is something that can divide into all of the pieces of the polynomial. So in this case, it has to divide into all 3 pieces. So let's start with the coefficient. What coefficient goes into 4, 6, and 10? 2. That part was easy. What about your variables? Do they all have an A?
Yes.
What's the biggest number of A's I can take out?
1.
Just 1, because the last 2 terms only have 1. So I'm going to take out an A. What about a B? Do they all have a B?
Yes.
The biggest number you can take out? Just 1. So that's my GCF, 2AB. And now it's dividing. 4A squared B divided by 2AB would be
4A.
No, 2A.
2A.
2A, I said.
6AB squared divided by 2AB would be
6B.
3B.
3B. And negative 10AB divided by 2AB would be
-5.
negative 5. If you want to check yourself, you
That's
can
not
go
bad.
back and redistribute that. You should be right back where you started.
Put a D where that 2 is. Like staff.
Yes. Yes, it is. Okay, is everybody okay with GCF?
so smart.
Now, if I had a polynomial, that looks like this. I look first at my coefficients. What coefficient or what number goes into all 3 of those numbers?
2.
Okay, what about x's?
No.
No, because this one doesn't have any x's.
2
But what about y?
2y.
Not
Y.
2. Just 1, because this one only has 1. You can't take away more than what you have. Does that make sense? So I can take 1 out of here, I can take 1 out of here, and I can take 1 out of here. There will still be 1 left. These won't have any left. Yes? Everybody good? Alright. Y'all remember doing this in 9th grade? Y'all gotta stop that forgetting stuff after the test.
Why we did this last grade?
We did it in 9th grade. Those of you who took 9th grade last year, you should totally do it. Okay, so that's your first thing. Every single question you're going to ask yourself, is there a GCF? You have to do that first. Then after that, the next easiest form of factoring is a difference of 2 squares. Now, it's called that because they have to be perfect squares. And it has to be a difference, which means it has to be subtraction. So because it's a difference of 2 perfect squares, this is only going to work for binomials with subtraction in the middle that happen to be perfect squares. Now, does everybody in here know your perfect squares?
Yes.
If you do not have them memorized, you must. At least through 13, and you should probably know 15 and 25. Because they show up, anybody know what 15 squared is?
225.
225. Anybody know what 25 squared is?
625.
625. Those show up a lot. And then 1 through 13. You should know those. If you don't know them, memorize them. Because remember, you do not get to keep your calculator on half of the SAT. They take it from you. And they expect you to know, y'all, my 9-year-old just learned his perfect squares. He's 9. So if my 9-year-old can memorize his perfect squares, you guys can memorize them too. Not just for the test. No, but he didn't learn them because of me. He learned them because he's in number sense in UIL. So I was like, all right, learn your perfect squares. So you should memorize them because you need to know them. It also makes this a whole lot easier if you know them. Okay, so you're going to be looking for perfect squares with subtraction in the middle. And then the factoring is just a pattern. Every single time you do it the same way. So the pattern is 2 sets of parentheses, One with a plus, one with a minus. It doesn't matter what order you put those in. If you prefer putting the minus first, go ahead, it doesn't matter. And then you take the square root of the first number and you put it in both first spots. So the square root of a squared is just a, right? Because a times a is a squared. So you put an a in both places. And the square root of b squared is just b, and they put a b in both places. That's it. I mean, it's easy.
How do you
Nothing
put
to it.
plus and minus? You just stop. You
It doesn't matter. It's always a plus, always one plus, one minus. Always works that way, every time. Okay, but don't forget, you have to first ask yourself, is there a GCF? So on this first example, is there a GCF between these two numbers?
Yes.
Really?
3.
No.
It's not 3.
Does 3 go to 64?
No.
Never has, never will. Not evenly anyway. So there's no GCF this time, so I'm just going to leave that blank. But I do notice 9 is a perfect square, 64 is a perfect square, x squared is a perfect square, y squared is a perfect square, and there's minus in the middle. So this is a difference of two squares.
Yeah.
So you just follow the pattern, two sets of parentheses. One has a plus, one has a minus. Take the square root of the first term. What would the square root of 9x squared be?
3x.
3x, and that goes in the first blank of each parentheses. Then you take the square root of the last term,
A1. Negative A1.
just 8y, and you put it in the last blank.
That's it.
And that is it.
Dude, that's easy.
So easy, right?
Well, I didn't
So
see how
easy.
you don't say that.
No, for real, this doesn't get any harder. The only thing that makes it harder is that this is only one way to factor. So you just have to remember this and the other 4 ways that we're going to learn. But it's okay. Okay, so next one, GCF. You have to ask yourself, is there a GCF?
5.
5. You've got to take that GCF out, because if you don't, are those perfect squares? No. But if you recognize there's a GCF of 5, that would make this 4x squared minus 9. Now this is a difference of two perfect squares. Okay, so you factor that the same way. It's the same way every time. It's a pattern. Two sets of parentheses. One has a plus, one has a minus. It does not matter what you list first, because multiplication is commutative. What does that mean? Multiplication is commutative.
Is it the same?
Works in all ways.
In any order. Multiplication can be done in any order. So it doesn't, this is multiplication, so it doesn't matter if the minus is here, it doesn't matter. Because it can be done in any order. Okay, square root of the first term goes in the first blank. 2x. Square root of the last term goes in the last blank. The only thing you have to remember is that there was a GCF. It has to be in the problem, because you have to be able to multiply and get all the way back where you started, and without that 5 we wouldn't get there. We'd only get this.
So do you just divide by that?
You don't do anything, it's just right there. Everybody okay? So far so good?
Perfect.
Alright, good. So now, keep this packet, because this is our factoring packet. So you can see if you flip to the next page, it jumps on to difference of cubes. We're not going to do that today. We're going to stick with GCF and difference of two perfect squares, but we'll start difference in sums of cubes on Monday.
She says it's not going to be hard.
Ms. Wahani, could I please rush?
Yes.
First time I said it's going to get easier. First time I said it's easy, I said it's not going to get hard.
This isn't.
It's going to get hard.
Look, there's 27 questions on here. I bet you can finish this 27 questions, because it's not any harder.
Last time I said it's easy, I said, oh, it gets harder.
Well, this gets harder too, but not this. Difference of squares is but factors gets harder.
I don't know if it's supposed to multiply. Two equations?
I started the campaign.
What's the hardest one? Oh, no.
Factoring trinomials with a coefficient other than 1, probably.